Okay, so today we're going to be writing the equation of a line. So we're going to be looking at standard form and slope-intercept form again. So if you remember from yesterday, the standard form of a linear equation is ax plus by equals c. Okay, so on a standard form, it says a must be positive, and then it also must be an integer. An integer means a whole number, so just make sure when you are putting it in standard form that a, which is the coefficient of x, has to be positive and it has to be a whole number. The slope-intercept form is y equals mx plus b. We talked about that yesterday. M is your slope, b is your y-intercept. Okay, so what we're going to do here is we're going to write the equation of each line using the given information. So number 1 and number 2, we're given a graph. Number 1, we're going to put it in slope-intercept form. And when you're given a graph, in order to write the equation, there's two things that you need to know. You need to know the slope, and you need to know the y-intercept. So you're going to have to find that anytime you're given a graph. So the slope, you're going to pick one of the points. And then remember, slope is rise over run. So I'm having to go up 2 to get to the next point, which is positive, and then left 5. So it should be a negative 2/5 for the slope. If you had started with the other point, you would have went down to right 5, which still would have been an overall negative 2/5. The y-intercept, it's crossing at 7. So once we know m and b, since we're plugging into the slope-intercept form, it would be y equals negative 2/5 x plus 7. And that's the form that you wanted in. Okay, so number 2, it wants it in standard form, but you're still going to have to find the same two things from the graph, the slope and the y-intercept. So pick a point. I'll pick that one. It goes up 1, 2, 3. And goes to the right 1, so overall that's a positive 3. If you had chose the other point, it would have been down 3, which is negative, left 1, which is negative, but a negative divided by negative is a positive. Okay, so your y-intercept is negative 4. So anytime you know slope and y-intercept, you're going to go ahead and plug it into slope-intercept form, even though it wants it in standard form, so you have to do that first. So y equals 3x minus 4. But we want standard form, so we want x and y on the same side of the equation. So I'm going to subtract 3x. So that's negative 3x plus y equals a negative 4. Now, remember we said at the beginning, a needs to be positive and an integer, which is a whole number. So notice a, which is the coefficient of x, it's negative 3. So what I need to do here is multiply by a negative 1 by every single term on the equation. So that way it becomes positive. So that's 3x. That now becomes minus y, and that becomes positive 4. So anytime you need to change from a negative to a positive, when you multiply by a negative 1, all it does is it changes the sign of every single term. So there's our standard form equation. So when you're given two graphs, just make sure that you are finding the slope and the y-intercept of your graph. Okay, so number 3, this time we're given the slope, which is a negative 1/2, the y-intercept, which is 6. Okay, so your y-intercept is the same thing as b. We're putting it in standard form. I'm going to go ahead and plug it into slope-intercept form first, and then we can change it to standard. So I want x and y to be on the same side of the equation. So I'm adding the 1/2 x over. So that's 1/2 x plus y equals 6. Now remember, on your standard form, when you're putting it in standard form, a, which is the coefficient of x, has to be positive and it has to be a whole number. Notice it's a positive 1/2. So to get rid of the fraction, I'm multiplying by the denominator. The denominator is 2. When you do that, you have to multiply every single term times 2. So 2 times 1/2 x would just be x. 2 times y would be 2y. And then don't forget about the 6. 2 times 6 would be 12. So there's your standard form. To check that, you could just solve for y, and it should give you back your slope-intercept form. So that would be your standard form equation there. Okay, so let's look at 4. On this one, we are given the slope and a point. We want it in slope-intercept form. So anytime you are given slope and point, you're going to plug into the point slope form. So the point slope form is on your formula chart. It's y minus y1 equals m times x minus x1. So on your point, this is x1 and this is y1. So you're not ever going to plug in for that first y. So y minus y1 of the point is 2 equals your slope, which is 1/3, times x minus the x value of your point, which is 4. Okay, so we are wanting it in slope-intercept form. So we're going to distribute next. So that's 1/3 x. 1/3 times a -4 is a -4/3, because you're just doing 1 times 4 to get 4, and then your denominator is 3. Okay, so next part, we're going to add 2 because we want to get y by itself, because we want it in slope-intercept form. So you get y equals 1/3 x. Now right here, we're going to have to add these together, so we have to have a common denominator. So we want the denominator to be a 3. So I'm putting a 3 here, which means I need to multiply that 2 by a 3 as well. So that should give you a 6/3. So you're only going to combine the numerators, which would give you a positive 2 over your denominator, which is 3. So -4/3 plus 6/3 would give you 2/3. That's the form that we want it in, and we don't care. We can have fractions in slope-intercept form. So that is our final answer. Okay, so let's look at number 5. On this one, the slope is undefined. We talked about that yesterday. That means it's a straight vertical line. And then it passes through the point 2,4. We want it in standard form. So on this one, I'm going to go ahead and just draw a graph so that way we can see it visually. So I'm plotting the point 2,4. So we know that the slope is undefined, which means a straight vertical line, and it passes through that point that we just plotted. So it should look like this. If we have a vertical line, this vertical line right here, every single x value that is on this line is going to be 2. So x equals 2 is your equation, because every single x value will be 2 there. That's all you have to do. So anytime your slope is undefined, it's always going to be x equals whatever the x value is. So if this had said slope is 0 and it passes through 2, 4, that would be y equals 4, because all of the y values would be the same, which would be 4. Okay, so number 6. Slope is 1/2. And then the x-intercept is -16. That is not the y-intercept, which is b. We don't plug that in for b. So, and we want it in slope-intercept form. So anytime you're given an x-intercept, you want to change that to a point. So we know when we have an x-intercept, y is 0. So that would be negative 16, 0 as a point. So anytime we know point and slope, we're going to use point-slope form, like we did on number 4. So y minus, our y value of the point is 0, equals 1/2 times x minus a negative 16, which would make it positive 16. And you get y equals, distribute, 1/2 x, and then 1/2 times 16, which means 16 divided by 2 gives you 8. That's the form that we wanted in, so that is our answer. So make sure if you're given slope and x-intercept, change that x-intercept to a point. That is not b. Plug it into a point-slope form, and then you should have your slope-intercept form after that. Okay, let's look at 7. So this one, it says it passes through the points -2, 5, -4, -1. We want it in slope-intercept form. So if you remember from the front, we were given slope, or we found slope on all of them. You have to know slope before you can find anything else on your equation. So that's going to be our first step here, is to find the slope. So remember, your slope formula is y2 minus y1 over x2 minus x1. So finding the slope, our y2 is -1 minus 5 over -4 minus a -2, which would make it +2. So that would be -6 over a -2. So overall, that would be a +3. So once we know slope, then we're going to choose one of the points that it passes through. It doesn't matter which one. I'm just going to pick the first one, but you could also use -4, -1. So once we know slope and a point, then you're using that point-slope form that we talked about on the front. So plugging into that, we're going to have y minus the y value of the point that we're choosing is 5, equals m, which we found on the first step, which is 3. Excuse me. And then x minus the x value of the point, which is 2. And then we distribute. So 3x plus 6. And we want it in slope-intercept form, so I want y by itself. So I'm going to add 5. So you should get y equals 3x plus 11 for your equation. Okay, so anytime you're given 2 points, make sure you're listening carefully. Anytime you're given 2 points, before you start doing all this work like we did on number 7, look at your points closely. So look at number 8. Notice here that the y values are exactly the same, which means you would have a 0 slope. If the y values are exactly the same, whatever y value that is your equation. 0 slope, it's just y equals 5. So if you were given 5, -3, 5, 7, that would be x equals 5, because they share the same x value, it equals 5. So make sure you're paying attention to your points, because it's really easy whenever the x's are the same or the y's are the same when you're finding a linear equation. Okay, so we're stopping here, and then we'll finish up the next 4 tomorrow.